Welcome to qnawire.
Problem 7.49, we're helping a circus performer construct a new spring cannon for him to do acrobatics or something with. I'm not sure what you call it. Anyway, this will have a spring with a spring constant of 1,100 newtons per meter. He's going to initially compress it with a force of 4,400 newtons. The inside of the gun is going to exert a force of 40 newtons with friction over the 4 meters of travel that he will be experiencing as he's pushed out of it. It starts from rest, and we want to find how fast he's going when he exits the gun 2.5 meters above where he started. So this is a conservation of energy problem. Is just a little bit involved, but nothing that we aren't prepared to do. So in order to use the conservation of energy, of course, we're first going to want to know what the energy stored in this spring is, which requires knowing how far it's compressed. So the compression of the spring is just going to be the initial force divided by its spring constant. So it's going to be compressed by 4 meters because 4,400 is 4 times 1,100. Now let's call his initial height y equals 0, so that y final will just be our 2.5 meters. And we can write out our conservation of energy equation now. So we know that the initial potential, kinetic, and then other work done has to equal final potential and kinetic energy. And this is going to give us the final speed. So we have, this is initially 0 because he's starting off from what we're calling y equals 0. So we have a 1/2 kx squared. X is the 4 meters we just found. And then the work friction does, we're just told the force. So it's F times S. S is the 4 meter length along which he's going to be sliding through the tube. Now this has to be equal to, the potential energy is going to be mg times y final. That'll be our 2.5 meters. Plus 1/2 m v final, which is what we don't need to know, squared. So we just solve this for v final. We will get the square root. So it's going to move this over here, multiply everything by 2, and then divide by m before taking the square root. So I have 1 over m here, say. So we'll have k x squared minus 2 fs minus m gyf. And so then this is speed ends up being 15.5 meters per second when you work through the numbers of this.